Hi, Dr. Doobie here. Today I'm going to show you how to use Solver in Excel. Here we have the single stage separator for benzene and toluene that you have seen before. We're feeding 100 moles per second of the mixture and it is 40% benzene. The process specification will be that the vapor is twice the liquid flow rate and the pressure is 760. So we have a guessed temperature of 105 degrees C, guessed vapor flow rate and composition, guessed liquid flow rate and composition. These are the K values calculated from Antoine's equation, and it's the vapor pressure divided by the total pressure. And over here are objective equations. The total mole balance, benzene mole balance, equilibrium for both benzene and toluene, and that process specification. That's 5 objective equations, so we will be varying 5 things. That will be the temperature, vapor flow rate, composition, liquid flow rate, and composition. That's an awful lot of equations to solve by hand, so instead we'll use the solver application in Excel. The first thing to do is set the objective functions. Here you see we have the cell N3, which is the total mole balance, as an objective, and we set that to a value of 0. Also, the constraints are also objective functions, and here we have N4 to N7. That is the benzene mole balance, equilibrium, and for benzene and toluene, and the process specification. They all have to equal 0 also. Then we specify the variables that can be changed so that these objective functions can be reached 0. And those changes will occur for the temperature, the vapor flow rate, its composition, liquid flow rate, and its composition. So we have 5 equations, 5 unknowns. Now all we need to do is press solve, and a routine is used by Solver to efficiently come up with an answer. So Solver has now come up with an answer, and instead of 105 degrees, I think I guessed here, we have 99.7 degrees. Vapor flow rate is 2/3 of the total, and liquid flow rate is 1/3. And here are the compositions. So these set of variables satisfy all 5 equations. Try doing that by hand sometime, and you will appreciate the solver function. One of the beauties of an Excel simulation is you can play around with the process specifications all day long and learn how it affects the results. For instance, here I want to change the temperature to 96. We'll actually specify it to be that. Well, no longer will the process specification be met if we do that. But what will the product flow rates and compositions do in response to that? So now we call up Solver and make a few changes. The first one is that we no longer have the temperature in the changing variable cells. So we're not going to change this. We're going to keep it at 96 degrees centigrade. Then, for the constraints, you see here I just have N4 to N6, which is the benzene mole balance down to the toluene equilibrium, but not the process specification. We're not going to try and have it be met because it can't be at that temperature. Notice that we now have 4 equations and 4 unknowns. So here's the solution for this new specification of 96 degrees C, and we have less vapor produced at this lower temperature, as you might expect. All the objective functions have been met, except for the process specification. We can't reach 2/3 vapor with this particular process temperature. Most analysis that we will be looking at in this course involved multiple coupled algebraic equations that are almost impossible to solve by hand. And so if we use Excel to solve these problems, we will be using Solver a lot. It'd be useful to become expert at using this tool.